In this video, I'm going to be repairing this Mac Pro 5.1 dual CPU tray, which I recently purchased off eBay for about $100. Now, of course, I did buy it off eBay as is non-working, and at least according to the listing, the only issue was this connector right here was broken off the board. As you can see, it did indeed rip all 4 pads off the board with it when it was pulled off. So unfortunately, that means there's no real place to mount this connector anymore, because of course all these pads are off. Now, luckily for us, we can see that the traces for this connector are very visible. So you can see there are just 2 traces that run along the board there. They just run down here to this chip right here. And then as you can see, there is a capacitor right here that sandwiches or is just right in between each of those lines. So what I need to decide on now is whether or not I just want to cut this wire off right at the heatsink basically, and then just solder some of the enamel-coated copper jumper wire to that capacitor and just have a permanently installed setup, or attempt to mount this connector back on the board somewhere and see if I can just run the wires to the connector, allowing you to still unplug and plug back in the thermal sensor for the Northbridge heatsink. So the only issue there is there's very limited space in between the 2 CPU heatsinks and the connector itself, so you really only get this very small window of space to mount it. And unfortunately, there's no other grounding pads in this area that I can just solder the connector, the sides of the connector onto. So an option is I could just use some hot glue to hold it down. That's not a very good option because that tends to come off quite easily. Or I can just permanently install the heatsink, and more than likely that's what I'll probably do. So I'm going to go ahead and pause the video here, get everything set up for what I end up deciding on doing, and then we will begin the process of soldering these wires or the connector back to this little capacitor as they're supposed to go. So with that, I'll go ahead and pause the video here and resume it once I am ready to begin soldering. Alrighty, so after a bit of thought, I decided instead of trying to glue the connector down, since it was just soldered to a ground plane, I'll just scrape away some of the excess solder mask right below where the original ground pads were originally soldered, and then just solder it right below where they were. So I'll just move the connector ever so slightly down. That way I'll still be able to solder the wires just going straight back to that capacitor, and the connector will still be securely attached to the board, allowing it to be unplugged and plugged back in like it was originally intended. So I'm going to go ahead and get the camera and the tripod and finish up doing this scraping, and then once I scrape all the solder mask back, we can go ahead and get the soldering iron out and solder the connector to those pads and then solder the wires. So with that, I'm going to go ahead and get the camera and the tripod and then resume the video. Alright, so I'm just going to continue scraping. As you can see, I already scraped this one here almost completely. I still need to do a little bit more to it, but this one I'll just scrape to around the same area, and then we should be able to solder the connector on there no problem. So let me finish up this one. Alright, so that's pretty well scraped there. We have 2 exposed pads on the ground plane, and we can of course test those and make sure they are indeed ground using the multimeter. So I'll go ahead and test those real quick. You can see they have continuity, and they also have continuity with the CPU socket housing there. So that is definitely a ground plane. So now what we'll go ahead and do is just get the soldering iron out and apply some solder to these pads and prepare to install the CPU or the connector that was ripped off the board. Okay, so as you can see, we've got a nice amount of solder applied to the pads now. Let me get this out of the way a little bit so we can actually see a little bit better. There we go. And the next thing we need to do, as you can see here, the connector itself has the pads still stuck to it from when it was ripped off the board. So now what we'll have to do is just remove those pads, and we should be able to do that using a soldering iron without much of a problem. There we go. Alright, so as you can see there, the connector has now been completely cleaned. So now what we can go ahead and do is just solder it onto the board. Actually, what I'm going to do real quick here is just wick a little bit off of those pads. Alright, so as you can see there, both of the sides of the connector have been firmly attached to the board. So now what we can go ahead and do is just get rid of these old traces right here, because we really don't need that sticking up off the board anymore. So I'm just going to go ahead and cut that off. Just like that. And now what we can go ahead and do is just solder some wires from this capacitor right here, either side of it, to the 2 pins of the connector. Now if you look closely at the connector, you can actually see that the trace that went from here up to here, so this pin connects to this one, and this trace connects to this pin, but you can see up here that one of them kind of wraps around here and goes down, so it's actually this pin that connects to the outside trace, and then this pin that connects to the inside trace. So that makes sense there. Actually, this one is the inside trace, that one is the outside trace. So we'll just wire it accordingly. And at the end of the day, this is just a transistor, so it shouldn't really matter which way you solder it to this connector. So I'm just going to cut the wire to length here and solder it to the appropriate pin. Okay, so there's the first wire soldered. Alright, so as you can see there, we've gotten the 2 wires soldered. As I mentioned, the inside pin here on the closest to this northbridge heatsink here actually goes to the first pin over here on the connector. So it goes to this pin right here, which goes to that pin right there, and then vice versa for the other pin. So now that that's all wired up correctly, we can go ahead and clean all this flux off the board, install both of the CPU heatsinks with the CPUs that were already installed in the board, test it, and see if it actually works. So I'm going to go ahead and pause the video here, clean all the flux, and resume it once we're ready to test the board. Alright, so as you can see here, I have installed the CPU heatsinks. I've also installed a bit of memory in the memory slots there. And you can see here, right in there, the repair we just performed. The capacitor they're soldered to is actually covered by that heatsink, but you can see the connector is slightly shifted down, and we've got those two enamel-coated copper wires connecting it to that capacitor as we showed earlier. So now I'm going to go ahead and install this into the machine, and we'll see if it works. Alright, and as you can see, the machine chimed, so let's see what we've got. Alright, so it's booting, so far so good. Go ahead and log in here. See, everything seems to be working just fine. Let's go ahead into About This Mac. And as you can see here, it detects two 2.4 gigahertz quad-core Intel Xeons. Now, I did leave the CPUs installed that were originally installed with the board, but as you can see, everything is working. You can see all 8 memory slots are detected. Let's go ahead into System Report here and see what we detect here. Alright, you can see 2 processors are detected. 8 cores total. There are 2 quad-core Xeons in there, and everything looks to be working perfectly. So one last thing to check here before we finish the video is the actual temperature reading of that thermal sensor we fixed, or the connector that we fixed. So let's go ahead and open this hardware monitor application. Go ahead and close out of that, and you can see all of the temperatures here. And the ones we're concerned about is Northbridge chip, and specifically Northbridge heatsink. As you can see, the Northbridge heatsink is only running, or is detected properly at 50 degrees. And if it wasn't detected properly, or if it wasn't connected, it would read either 0 degrees, or I believe the default value is like 128 degrees Celsius. So the fact that we are getting 50 degrees detected means that that thermal sensor is connected and working properly. So that has been the full repair of this cheap dual CPU tray for this Apple Mac Pro 5,1. Hope you enjoyed this video.